This repository provides the tools to run inference, training, and evaluation for 8 different versions of YOLO models. I've created .sh scripts to streamline the process, allowing you to switch between models with just a single line of code. Everything is highly customizable through multiple parameters, making it user-friendly and efficient. Experimental results are accessible both on Google Drive and directly within the GitHub repository for easy reference. Stay with me, and let me walk you through what this is all about. Hi everyone, and welcome to my channel. My name is Catargiu Constantin, and I'm currently pursuing a PhD at Gheorghe Asachi University in Iasi, Romania. My research focuses on computer vision and more specifically, on deep learning neural networks to solve complex and exciting problems in this field. In today's video, I'm thrilled to introduce a project I've been working on, a GitHub repository called All YOLO Models. The name comes from the fact that I've brought together 8 different versions of YOLO models into one place. What's even better is that with just one line of code, you can easily switch between versions to run evaluation, training, or inference depending on what you need. It's designed to make working with YOLO as smooth and efficient as possible. Whether you're just starting with object detection or you're a seasoned developer looking for a streamlined way to explore multiple YOLO versions, this repository has something for you. Stick around because I'll show you how this resource can simplify your workflow, save you time, and help you achieve better results. Let's dive in and get started. To kick things off, I'll start with a brief introduction to YOLO models. This will help you understand why I chose to use them and how they work. Once we've covered the basics, we'll return to the main topic of this video and explore it in more detail. What is YOLO? YOLO, short for You Only Look Once, is a family of deep learning models built for real-time object detection. Unlike traditional two-stage object detectors such as faster RCNN, which first generate region proposals and then classify them, YOLO takes a simpler and faster approach. It falls under the category of single-stage object detectors, predicting both the object class and its location via bounding boxes in a single pass through the network. This process is shown in Figure B. In comparison, the architecture of two-stage detectors like faster RCNN is illustrated in Figure C. When did YOLO appear? YOLO made its debut in 2015, introduced by Joseph Redman and his team in their research paper titled You Only Look Once, Unified Real-Time Object Detection. This groundbreaking work redefined object detection by combining the entire process into a single convolutional neural network. The evolution of the YOLO family over time is depicted in Figure A. How does YOLO work? YOLO simplifies the object detection process by treating it as a single regression problem, rather than dividing it into separate tasks like region proposal and classification. Here's how it works. Grid division. The input image is divided into a grid of cells, bounding boxes. Each cell predicts bounding boxes and confidence scores for objects. Class prediction. YOLO predicts the class probabilities for objects in each bounding box. Unified detection. The entire process is performed in a single forward pass of the neural network. This unified approach allows YOLO to process images extremely quickly while maintaining high accuracy. Why is YOLO useful? Real-time object detection. YOLO excels in identifying objects in both images and videos with minimal latency, making it a preferred choice for time-sensitive applications such as video surveillance, autonomous vehicle navigation, and robotic vision. Its speed ensures rapid processing without sacrificing accuracy, which is crucial for dynamic environments. Streamlined design. Unlike traditional object detection methods that involve multiple stages, such as region proposal and classification, YOLO combines these steps into a single, unified neural network. This streamlined architecture simplifies both the model's deployment and its computational requirements, making it efficient and easy to integrate into various systems. Versatile applications. YOLO's flexibility allows it to be adapted across a wide range of industries and use cases. In healthcare, it aids in medical imaging for detecting anomalies or diseases. In retail, it facilitates analytics such as customer behavior tracking and inventory management. Its adaptability to different tasks and environments makes YOLO a powerful tool in modern AI applications. That was a quick look at YOLO models. I hope it helped you understand a bit about how they work and got you interested in learning more about this exciting technology. There's a lot more to discover, so I encourage you to check it out. Next, let's dive into the main topic of this video, the GitHub repository I'm proposing for your use. With so many versions of the YOLO model available, currently the latest is YOLO11, it can be challenging to decide which one is best suited for a specific application. To help with this, I've tested several versions including YOLO5, YOLO6, YOLO7, YOLO8, YOLO9, YOLO10, YOLO11, and YOLO NAS. My testing process involved 3 key steps. Evaluation. I assess the models on test and validation datasets to understand their performance. Training. I trained each model on a custom dataset to evaluate how well they adapt to new data. Inference. I tested the models on video files and images to see how they perform in real-world scenarios. Through these experiments, I gained hands-on experience with the scripts provided by the original authors of these models in their respective repositories. Since these models are developed by different teams of scientists, their usage varies significantly. To simplify this, I've created a collection of .sh files in my GitHub repository. These files make it easier to use the training, evaluation, and inference scripts for any model with just one line of code. It's designed to save you time and make working with these models much more convenient. In these images, you can see how the GitHub page for the project is organized. I'll include the link in the video description. The project structure is designed for clarity and efficiency, with everything you need in one place. Experimental results. This folder contains subfolders for each model, storing results from evaluation, training, and inference tasks, along with model weights that are automatically downloaded if missing. Inside it, the metrics folder holds inference results and comparative metrics, offering a clear view of performance. Inference scripts. This folder has subfolders for each model, containing Python scripts I created or customized from original repositories to tailor inference tasks. These scripts are tested and working, so they shouldn't be modified. Utils. A utility folder with helpful scripts used during development, including YAML configurations for datasets like Coco and ImageNet, .sh files for downloading datasets, and a space to store the Coco dataset after download. Feel free to explore and experiment with these scripts. YOLO model. This folder is initially empty and meant to store models after cloning. The .sh files outside the folder structure play a critical role in streamlining the workflow by enabling you to switch between models effortlessly with just a single line of code. These scripts are designed to handle essential tasks such as downloading models, training, performing inference, exporting models, and evaluating their performance. Each script comes with specific parameters that allow you to customize and fine-tune the tasks according to your requirements. I plan to create specific videos for each script, explaining how they work and how to use them along with their parameters. This level of flexibility makes it easy to adapt the process for different models and datasets without manually altering code, saving time and minimizing errors. On the GitHub project page, I have included a comprehensive README file to guide users who want to utilize my work. The README provides instructions on how to clone the repository and explore the models included, with each major step of the project documented in its own section. The Quick Start section provides an overview of how to get started, including granting permissions for .sh files and cloning specific models, with detailed instructions available upon expanding the section. It is important to note that the repository is configured to run on a Linux operating system. The Evaluation Tasks section explains how to use the YOLO models eval.sh script and its parameters, featuring a table showcasing the results of evaluating each model on the Coco validation dataset. It also includes instructions for downloading the Coco dataset and viewing more detailed evaluation results. The Export Task section introduces the YOLO models export.sh script, which allows users to convert model weights into ONNX or TensorRT formats, outlining the steps and benefits of this process. The Inference section presents the YOLO models inference.sh script, its parameters, and their explanations, highlighting the main advantages of using this script. Finally, the Training Task section focuses on the YOLO models train.sh script, explaining its usage and detailing its parameters. By organizing the README in this way, users can easily follow the steps required for each task, ensuring a smooth experience when working with the repository. At the bottom of the README file, you will discover a comprehensive list of the key advantages of using the inference file from this repository for video validation. Each advantage is clearly articulated and supported by snapshot images that vividly showcase the benefits and capabilities of this approach. These visuals and explanations aim to help you understand why this methodology stands out. By reviewing these points, you can assess whether this implementation aligns with your specific needs and objectives as emphasized during the presentation. I've also created a suite of Python scripts designed to enhance post-inference analysis. These scripts are executed immediately after the inference task to provide a detailed evaluation of the model's performance. Key metrics generated include 1. Total detections for all classes. This metric offers a high-level overview of the model's ability to detect objects across various categories. 2. Average confidence scores for each class. Scores provide insights into the model's reliability for each detected class, enabling deeper understanding of its strengths and weaknesses. 3. Total detections per class. Metric drills down into the detection count for each specific class, offering a granular view of the model's performance. To ensure a fair comparison, I ran inference on the same video file across all models in the repository. From this, I generated 2 sets of comparison metrics, evaluates models using their native PyTorch weights and assesses performance with optimized engine weights. An overview of these comparison metrics is provided above the subtitle bar in this slide, offering a quick glance at the results. For a more detailed exploration of the metrics, please visit the repository's Comparison Evaluation Metrics section. These metrics are invaluable for identifying the top-performing model, giving you a clear direction for further experimentation or deployment. At the end of the README, you'll also find a link to a dedicated Google Drive folder containing the experimental results. This folder includes individual inference videos. Each model's performance is demonstrated on the same video file, allowing you to evaluate their capabilities independently. Comparative video, a side-by-side demonstration of all models running on the same video, providing a clear visual comparison of their performance. These resources are designed to provide you with both quantitative and qualitative insights into the results. The combination of detailed metrics and visual evidence ensures a thorough understanding of the model's strengths and weaknesses. Be sure to explore these materials to fully appreciate the performance differences and make an informed decision about the best model for your needs. In this video, I provide a brief demonstration of how to utilize this repository project. I begin by illustrating the process of downloading a model, using YOLO11 and YOLO9 as examples. The download models sh script is used to clone the models from their respective repositories, with an optional feature to automatically install the required dependencies for the cloned models. The next step involves performing inference on a short video to evaluate their capabilities. For this purpose, 2 specific versions of the models are utilized: the YOLO9 Gelency version and the YOLO8 medium version. The inference process applies the models to the video file, allowing them to detect and classify objects frame by frame. This step not only showcases the model's real-time performance but also their ability to handle different object detection scenarios within the video. After the inference task is completed, are generated detailed performance metrics for each model. These metrics provide insights such as the total number of detections across all frames, average confidence scores, and the detection count for each individual class. The next steps involve combining these metrics for comparison. By moving the metrics into the experimental results metric folder and running a Python script from the utils folder, a comprehensive comparison is created. This comparison file highlights key performance indicators, such as the total number of detections and the accuracy of each class, enabling users to determine which model performs best under the given conditions. Through this systematic approach, the repository not only facilitates inference but also ensures robust performance evaluation for informed decision-making. Thank you for watching my video. This is the first step in what I hope will be an exciting and inspiring series where I share my journey in the captivating world of deep learning and neural networks. I truly hope you enjoyed the content and found it valuable. If you did, please consider giving this video a like and a subscribe to the channel. It's free and hugely boosts my motivation to keep creating. If you have questions or feedback, don't hesitate to drop a comment on the video, or reach out to me via email or LinkedIn. Links are in the video description. As we kick off 2025, I want to wish you a happy new year. May this year bring you success, productivity, and positivity. Stay safe, and I can't wait to see you in the next video. Until then, take care and bye for now.